Today we are going to calculate oxidation state. So today we are learning how to calculate oxidation state. So let's see what are these points we have to keep in our mind while calculation of oxidation state of any element in a compound. So the first point is that oxidation state of any element in their elemental state is taken as 0. So if you are talking about O2, N2, P4, etc. all are in their elemental state. It means that in O2 the oxidation state of oxygen is 0. In N2 the oxidation state of nitrogen is 0. In P4 oxidation state of phosphorus is 0. In S8 compound the oxidation state of sulfur is 0. So oxidation state of element in their elemental state is always 0, or oxidation state of any element in the homoatomic compound is 0. Okay, fine. Second point, you have to remember that alkali metals have always oxidation state +1. And for alkaline metal, whenever you are seeing the alkali earth metal, you will always take the oxidation state +2. Oxygen always come as a -2 oxidation state. Oxygen will always come as -2, but we have some exception. When the oxygen will combine with alkali metal or alkaline earth metal, that time oxygen can show +2, can show -1, and even can show -1/2. You can check in this compound Na2O2. It is called as peroxide compound. So in this case, oxidation state of the oxygen is -1. It is called as peroxide compound. In H2O2 also, the oxidation state of oxygen is -1. In peroxide compound, oxygen come as -1. Okay. In superoxide like KO2, oxygen come as -1/2. Here the oxidation state of oxygen is -1/2. How we will see with the examples, how I am writing -1/2, how I am writing by -1. We will check that. But you have to remember that everywhere, whenever you are seeing oxygen, you have to take the oxygen state -2, except when it is combining with alkaline earth metal or the alkali metal. Okay. And one more thing, when the oxygen combine with fluorine, now it come with the plus oxidation state. Only with fluorine oxygen have plus oxidation state. Here the oxidation state of the oxygen is +1, and here the oxidation state of oxygen is +2. These are some exception of oxygen. Otherwise, oxygen always have -2 oxidation state. Okay. If we check for the fluorine, fluorine we know that highest electronegative atom in the periodic table. So we can say that fluorine always have -1 oxidation state. But for other halogen compound, when they are combining with the halogen compounds, means if their compounds are interhalogen compounds, that time they have -1. But other halogen compound like chlorine, bromine, iodine, they can have -1, they can have plus oxidation state also. So we have to calculate in the compounds. Okay. For hydrogen, oxidation state is always +1, except in the case of metal hydride. In metal hydride, hydrogen have oxidation state -1. They have oxidation state -1. Okay. So what we have to remember? First, the oxidation state of any element is 0 in the elemental state. Second, that for alkali always +1, alkaline always +2, oxygen always -2. We have some exception. Okay. Fluorine always -1, and hydrogen always +1, except in case of metal hydride. Now we will apply this concept for the calculation of the oxidation state of some compound. So there are some compound H2SO4, H2SO3, and H4 and all. We have to calculate the oxidation state of the elements where I have marked as X. Okay. Let's take the first compound H2SO4. But we have seen that oxygen will always have -2 except in superoxide, peroxide, and combination with fluorine. None of the cases here now. So we will take the oxidation state of oxygen here as -2. Okay. For hydrogen we know that oxidation state is always +1 except in case of metal hydride. We have to calculate for sulfur. Let the sulfur be X. Okay. Now this compound is a neutral compound. Now there is no overall charge in this compound. That's why we can write like that. X, oxidation state of sulfur, plus 2 into oxidation state of each hydrogen is how much? Plus 1. How many hydrogen we have? 2. So we can write 2 into plus 1. Oxidation state of oxygen is 4 into minus 2 is equal to what is the charge on the compound. As this compound is neutral, so we will equate this to 0. So we can calculate x is equal to, this will be minus 8, it will go as plus 8, okay, and it is plus 2, so it will go as minus 2. So here sulfur is in plus 6 oxidation state. Here sulfur is in plus 6 oxidation state. Now in H2SO3 we have to calculate sulfur is X, okay. Hydrogen plus 1, oxygen minus 2. We know when it will have a different oxidation state. Exceptions are there, okay. How many hydrogen we have? 2 hydrogen. Sum of all the oxidation state will be 0 here. Why? Because the compound is neutral. Sum of the hydrogen, 2 hydrogen, 1 hydrogen have plus 1. This is X. We don't know the sulfur oxidation state. We have 3 oxygen, 1 oxygen have minus 2, so equal to 0. We can see from here that it will be 6 minus 2, that is equal to 4 plus 4. So sulfur here is in plus 4 oxidation state, and in this H2SO4 sulfur is in plus 6 oxidation state. Okay. Check for the NH4 plus hydrogen. Only in case of metal hydride it is minus 1, always plus 1. It is not a metal. Okay. So hydrogen plus 1. We don't know for nitrogen. Let the nitrogen be X. It is not a neutral compound. It is a cationic compound. Overall charge is how much? Plus 1. So X into 4. We have hydrogen. 1 hydrogen have plus 1 is equal to plus 1. So we can check that here nitrogen is plus 1 minus 4, that is minus 3 oxidation state. In this case our nitrogen is minus 3 oxidation state. Next we have to check for K2Cr2O7. Let the Cr2 be X, let the chromium be X. Okay. So again it is a potassium alkali metal, always plus 1. So 2 into plus 1, okay, minus 2x plus 2x. 2 chromium we have now, so 2x we have to take. 1 chromium oxidation state we have taken as X. We have 7 oxygen, 1 oxygen have minus 2. So plus 7 into minus 2 is equal to neutral compound, no charge. You can check that here we have a plus 1 charge. It is a neutral compound. The sum of all the oxidation states should be 0. So we can check that it is 2x is equal to minus 14, it will go as plus 14. Okay, 14 minus 2, that is equal to 12. So we can say that x is equal to plus 6. So the oxidation state of 1 chromium here is plus 6. Now we have to check for cesium O2. Cesium belongs from the alkali metal. We know that alkali metal it belongs from the alkali metal, and alkali metal always have plus 1 oxidation state. And we know that at that time we have to decide for the oxygen. Whenever oxygen will come with alkali or alkaline earth metal, that time it will change. It can show minus 2 or it will show other oxidation state. But alkali always plus 1. So it will be plus 1. Let the oxygen be X. Compound is neutral now. So plus 1 plus 2x is equal to 0. So X is equal to minus 1 by 2. This is called as superoxide compound. Okay. Now for the MnO4 minus. Compound is not neutral. It is an anionic compound. We have a negative charge. So we will, how much negative charge? Minus 1. So we will equate the sum of oxidation state to minus 1. Let the oxidation state of manganese be X. It is an oxygen now. Here it will always come as minus 2. Okay. So X plus 4 into minus 2 is equal to minus 1. So X is equal to minus 1 plus 8, that is equal to plus 7. So here manganese is in plus 7 oxidation state. So remember those points, the exception, and like for a certain element we have always a fixed oxidation state, and for which it is unknown, you take this as a X and check compound is a neutral, cationic or anionic. According to that, equate the sum of all the oxidation state is equal to 0 or negative or positive. It will depend upon compound is anionic, cationic or neutral. So this is how we can calculate the oxidation state of any element in the compounds. Thank you.